Hi everyone! Welcome to my tutorial on making a fabric Arduino. First you will need 3 different types of materials: copper fabric, cotton fabric, and steam-a-seam. You will need the steam-a-seam to fuse the copper fabric to the cotton fabric after we cut out the circuit using a craft plotter. First, you're going to take the first layer off of the steam-a-seam, like so. Then you're going to take the copper fabric and you're going to put it over the steam-a-seam because this side is sticky. And you mostly want to make sure that it's on like very nice and straight. You probably want to cut it to fit the actual material. But you should save the excess material because you can use it again for something else. Next, you're going to take this sticky craft plotter mat that you can put into the craft plotter, and you're gonna put your double-sided copper steam-a-seam material onto the mat. So just line it up in the left-hand corner, and you can like press it down so it sticks. Okay, now we are ready to cut our circuit trace in the craft plotter. So now we cut the circuit on the copper fabric. You can see that there. You can see the trace being cut out. So now we want to cut some excess material out, and you can always save this for other projects, so just remember to save it. Now we will transfer the copper trace to the cotton fabric. We're going to peel off the backing of the steam-a-seam, and as you do it, you can see that the sticky part that will fuse together the copper and cotton fabric is now basically transferred directly onto the copper fabric. So you just carefully do it. And now we're going to place it onto the fabric, kind of right in the middle is probably good. Now we're going to do what's called weeding, and that's when you're taking all the excess fabric off so that only the trace will be seen. So as you can see here, I'm pulling it off, and one of the pads is going to stay on. So you're going to do that for the whole entire thing, and it might be helpful for you to cut the excess stuff off as you go, so you're not just having this huge piece of fabric just all stuck together. So now we have most of the excess fabric off. But, as you can see, sometimes it doesn't totally peel. So like, right here there's some extra sticky steamicine. And you can easily get this off by just taking an X-Acto knife and kind of like rubbing it off. Now we are ready to iron on the circuit. So you're going to take an iron, you're going to set it on the cotton setting if it has one. If not, it's probably okay. And you're going to just iron over it like so. And just the iron itself will fuse the two fabrics together. So yeah, now you have a circuit ironed on to the cotton fabric. And you can see it's kind of like you can kind of bend it, so it's like flexible. You might have to go over this a few times just to make sure it's completely on. And you might also want to try to trim any excess fabric that might be like fraying a little bit. Great! So now we have our fabric circuit. Now with this excess stuff that you cut out, you might want to put two pieces up here so you can externally power the board later. So I'm going to do that right away and I can show you. So you can probably just free cut like a very long T-shaped piece of fabric out. Like this. And you can put one here and one here for power and ground, and then you can externally power everything. So the same deal too is that you can peel off the back and then iron it on. So yeah, those are just two extra things you can add. You don't have to add those two things. Now we are ready to solder the components to the board. These are the things you will need. You need 10 of these female jumper cables, some wire, an Atmega 328P microcontroller chip, which is usually used on the Arduino Uno, and you can also have a socket for the chip. You need a 0.1 microfarad capacitor, a 16 megahertz crystal oscillator, and two 22 picofarad capacitors. First, we can start connecting all of the female jumper wires to the board. First, we will connect one to this pad on the board. This pad will eventually connect to a cable called an FTDI cable, and an FTDI cable allows you to have USB serial communication with computers, so you can upload code right to the board. And usually they have several connectors coming out of one wire or one long cable, and we can use jumper wires and connect these easily to the board. And you can unconnect them too as well, so it makes it super easy. The trick is to solder very quickly so you don't burn the fabric. And right now I have my soldering station at 640 degrees Fahrenheit. So it only takes a little bit of solder, just like that. And then we will solder these wires to pins 2 and 3, which is the RXD and TXD. Next we will solder the power and the ground. And the power is pin number 7. And ground is pin number 8. And we're going to solder it to this pad because we still have to solder some components onto the board using the other pads. Great, so these are the ones we have to solder onto this side. We will now start to solder the components. So we're going to take our 0.1 microfarad capacitor and we're going to bend both of the pins outward so it will stand straight up. So you'll make like this 90-degree angle with both of them. And we can use a little bit of tape to keep it down while we solder one side, which makes it a lot easier. Next, we can take our 16 megahertz crystal oscillator and do the same thing with the pins. And we will connect this from 9 to 10, like that. Pins 9 to 10. Next, we can do the same thing with one of our 22 picofarad capacitors and bend the pins out a little bit. And we can also connect one of these from 8 to 9, pins 8 to 9. And last but not least, we can take our last 22 and connect that from 8 to 10, pins 8 to 10. Great, so now we have one side of our board done. On the other side, we can continue using these female jumper wires, and you can we can have it so that you can hook up an external power supply. So like you can use like a 5-volt power supply, and so then one of these will be ground and one of these will be power. And we can also connect one on the other side, so you can connect power and ground from a sensor, so the sensors can be powered externally. Next, we need to ground the external power source to the ground on the board, the main circuit part. So we're going to take this wire and we're going to connect it to pad number 22. Awesome, so the last thing we have to do is connect the chip. So we're going to put our microcontroller chip into the socket. Before we do that, actually, we're gonna flatten these pins outwards so it'll sit flat on the fabric. So see, they're flat now. And we'll just stick it on our board like so. You might have to move the pins a little bit to make sure that they line up with the trace. So now we're going to solder each one carefully to the trace. Great, so now we're going to do the other side. This is what, before we do it, this is what it should look like. Just like tiny bits of solder, making sure the board is connected to each of the trace lines. Again, you might have to adjust the pins. Great, so now we have all the components connected. Now we will connect the board to our computer using the FTDI cable. First, we should connect the power and the ground. The ground is the black wire. So we can just take a jumper cable and then just plug it in like that. And we can plug it in to ground on our board. The red is power, and we can plug that into power. We're going to plug the yellow, which is the reset, into our reset pad. And then we're going to plug in the green, which is TXD, and we're going to plug that into RXD pin, which is number 2. And then we're going to plug the white, which is RXD, the white one, into TXD. Which is pin number 3. Our last step is checking all the connections with a multimeter. So you can just take your multimeter and test to make sure that each thing is getting power. So if you just test power and ground first, you should be getting about almost 5 volts. And then from there you just can check if you keep ground on ground, you can check each one of these individually.